Okay, this is the problem we were seeing. We have not that. Yeah, so this we had plotted. Yes, this magnitude, and we tried understanding what is this magnitude, and magnitude very clearly says that this x of n ranges from minus infinity to plus infinity. Okay, we were able to sketch that like this. Yes, uh, then we found out the z transform of that. Fine. By looking into the standard transforms of this. This is a power n u of n type. This is minus b power n u of minus n minus 1 type. So we had adjusted this to become the standard transform. Okay, we never have minus n in the power. So we tried making this as plus n by taking this 2 to the denominator, 2 to the numerator. So it becomes 2 pi n. Okay, so we had made such modifications to get the standard signal, and this is what we got as the x of z. Since we have positive time exponential, negative time exponential, this is a ring. Okay, in z plane, the ROC, region of convergence, is a ring in z plane. Okay, now I asked you to plot this graph. Okay, with ROC ranging from half to 2. Okay, for z greater than half and z less than, so it's a ring. Okay, and where will we have our zeros and poles? We have a pole at z equal to half, and we have another pole at z equal to 2. So 2 poles we have, so that needs to be marked. Okay, and we have a 0 at z equal to 0. If this z is substituted as 0, x of z would be 0. So we have a 0 at z is equal to 0. So there is just 1 0. But we have 2 poles. One pole is at z equal to half, because if I substitute this z equal to half here, so half minus half would become 0 in the denominator, and this whole stuff would get infinity. So we have a pole at z equal to half. Similarly, we have a pole at z equal to 2. So we have 2 poles and a 0. So this is what I wanted you to plot. So with that, we will go on with the next problem. That is this. Find the z transform of, see, n a power n u of n. Fine. Now just don't see this. Fine. Let's just understand this. What's happening here? What's happening here? Let's understand. They have asked us to find out the z transform of this. Okay. Now you should be able to extract a standard signal. Can you see a standard signal? Is u of minus n a standard signal? No, u of n is a standard signal. Okay, we have time reversed u of n. So u of n is one standard signal that we can make out. There is another standard signal. See this? There is another standard signal, that is half power n. Half power n u of n. So we have half power n u of n is another standard signal. Okay, it's not only that standard signal, but we have combination of that with n. So it is n half power n u of n. So we have some standard signals and combination of that with another standard signal, and some operations performed on that. Which operation being performed on that? Time reversal. So how to find out the z transform of this? So we need to build from the basic signal, that is this. Everybody understand? Okay, we need to build the z transform of this starting from the most basic signal that is available here. Most basic signal is u of n, but we also know what is alpha n, alpha power n u of n. Okay, so let's take alpha power n u of n. What is this signal? Which signal is this? Do we know this signal? Yes. Which signal is this? This is positive time exponential. And we have derived that the z transform of positive time exponential will be z by z minus alpha. In place of a, we have alpha. That's why I'm talking about alpha here. So z transform of alpha power n u of n is z by z minus alpha. Okay, and the region of convergence is outside the circle with radius alpha. Why do we talk about circle here? Because we are talking about infinite sequences. And which infinite sequence we are talking about? Are we talking about the positive time sequence, or we are talking about negative time sequence, this is positive time sequence. If it is positive time sequence, it is outside the circle. If it is negative time sequence, it is inside the circle. It need not be the positive time exponential or negative time exponential. It should be just any positive time signal, any negative time signal. For any positive time signal, it is outside the circle. For any negative time signal, it is inside the circle. Understand this. Now it is outside the circle with radius alpha. Everyone understand this? It is outside the circle with radius alpha. So that is here. So this is one thing. But this is not what they have asked us. Fine, this is not what they've asked us. We have alpha power minus n, we have u of minus n. That needs to be obtained. So how to obtain that? Needs to be looked at. Okay, see here, one way of obtaining this from this, I'll teach you now. Okay, so first let's go to attach a negative sign to this alpha. See here we have alpha power and u of n, right? But here we have alpha power minus and u of minus 1. Let's not bother about this minus as of now. Let's go with this minus. So I'm applying the minus here. See here, alpha power minus n u of n. But alpha power minus n u of n is not a standard signal because you have minus here. We have not dealt with a negative power till now in a standard signal. So can we make this as a positive power? Yes, we can make this as a positive power by writing this as 1 by alpha to the power n. Everybody understand that? Hope you are making a note of this. Everybody keep the book in front of you. Okay, keep on noting whatever is being taught. Okay, that is when you can focus. Otherwise there will be too many distractions. So without getting distraction, if you have to sit and learn, keep a book in front of you and go on making a note. All the equations are very clearly presented there, and I'm explaining each and every bit of the equation, so you need to find this easier to understand. Fine. Okay, so this is what we have. Now from this we are trying to get the z transform of this. Okay, so first thing, the what is that we are doing? We are doing alpha to the power of minus n. I attach minus sign here. Since we have attached minus sign, I can read this as 1 by alpha to the power n. So now in place of alpha we have 1 by alpha. So how would this z transform look like? This z transform would now look like z by z minus alpha 1 by alpha. Everybody is okay with this? Quite a simple step, provided you know which basic signal we are starting from. We are starting from a basic signal alpha power n u of n, which is positive time exponential. Once we have the z transform of that, ROC of that, let's go one step ahead to reach this particular signal. So how do we need to do that? We need to bring in this minus and we need to bring in this minus also. How to bring this? Which among these two we are bringing first? We are bringing this minus first. Okay, so after bringing this minus first, alpha power minus n can be written as 1 by alpha power n. Again, this is a standard transform. This is a power n u of n type, a power n u of n z by z minus a type. So in place of a, we have 1 by alpha, so it is z by z minus alpha. So in place of a, you have, in place of alpha, you have 1 by alpha, right? In place of alpha, you have 1 by alpha. So ROC is z greater than 1 by alpha. Is this understood? Everybody understand this now? Okay. Now, let's attach negative sign to this also. Everybody is okay with this? Let's attach negative sign to this n also. Okay. Now, after we attach a negative sign to that n, okay, can we use any of the properties which will readily give us the z transform of that signal by negating n? U of n, we know u of n is the z transform of u of n is z by z minus 1 with ROC z greater than 1. Okay, so if we do u of minus n, which property will come to picture now? The time reversal property. Understand that? So see what time reversal property tells you. Using the time reversal property, we know the Z transform of the time reverse signal is x of 1 by z. If it is not time reversed, it is x of z. If it is time reversed in z domain, in place of z, you will have 1 by z. That's it. What is x of z here? X of z is z transform of x of n. So if x of n is made x of minus n, in place of z, you substitute 1 by z. That is what time reversal property is telling you. Now, that is what we are going to do. We are time reversing this. If we time reverse, okay, what should happen to the z transform of this? Let's understand that. Now, let's take this as our x of n. Understand, this is our x of n, and we know the z transform of x of n is this. See, this is x of n and it is z transform of x of n. Let's consider this as our x of n. So we know z transform of x of n is this. Then what is z transform of x of minus n is what we need to look at. Okay, so in this place, in x of z, we need to substitute z as z 1 by z. So if you substitute z as 1 by z, it would become z inverse. This z would also become z inverse, and 1 by alpha would be 1 by alpha. And how would the arrows change? In place of z, we need to have z inverse. So this would become 1 by z. So ROC would become z less than alpha. So this is z transform of only this. We started from here, we got here, now we have got here. So we have taken 3 steps to reach this particular signal, but there is another signal associated with that is n. We still have not dealt with this, mind you. Okay, now after getting the z transform of this, suppose this is referred to as x of n. It is n x of n. So which property holds good when we have n x of n? Which property holds good when we have n x of n in time domain? If you have taken that, can you refer to that? Which property holds good when we have n x of n? Okay, so that property is this. Anyways, we have obtained. The next property from differentiation in time domain property, we can see that if you have x of n, it is x of z. If you have n x of n, it is minus z times differentiation of x of z with respect to z. See, if you have x of n, it is x of z. If you have n x of n, it is minus z differentiation of x of z with respect to z. Now, let's consider this as x of n now. Let's bring n here. What would happen if you bring n here? What would happen to this? So it would be minus z times d by dz of this. So that is what we are going to see in our next. So what have we done? In this place, we have brought n. So n into any signal can be solved using differentiation in z domain property. What is the differentiation? Why it is called as differentiation in z domain? See, there is differential in z domain. This is z domain. This is time domain. In z domain, there is differentiation of x of z with respect to z. And when would that differentiation would be there on z domain? It would be there when you are multiplying n to a signal. So we are multiplying this n to this signal, for which we already know the z transform. So this would be minus z times d by dz of z transform of this. Something that we obtained already, the z transform of this. And z transform of this is this signal. So if you do the differentiation of this, you can see that our z transform of n alpha power minus n u of minus 1 would happen to be this. You just have to differentiate this. What is differentiation of 1 by x? It is minus 1 by x square, right? So it is minus 1 by x square. So it is minus 1 by denominator square. Let's say it is there, minus 1 by denominator square. Okay, in the denominator along with z, since we are differentiating with respect to z, this alpha inverse should come here along with that minus. So in the denominator it is minus alpha inverse along with this minus z. So it would become alpha inverse into z divided by the denominator square. This is How? We need to obtain the Z transform of n alpha power minus n u of minus n. How did we start? We started with alpha power u of n, then we obtained alpha power minus n u of n, then we obtained alpha power minus n u of minus n, then we obtained alpha power n multiply to that particular signal. Okay, this is how it is happening. Go through this, sit, read each and every step, understand what's happening. Yes, you will not be very comfortable solving this problem if you don't know the properties of Z transforms. Here we have used two properties of Z transform. One is time reversal property, another one is differentiation in Z domain property. Time reversal property is if you have x of n, then what is x of minus n? Z transform x of minus n is what we'll do in time reversal. In differentiation in Z domain, what we do, if you are multiplying n to a signal whose Z transform you know, that is when we go for differentiation in Z domain property. Okay, so if you know these properties and if you know which how to approach the problem, this should be easier to you. Fine. You just need to practice. Okay, whatever things I've been providing with you, okay, just practice. You'll not have any problems. Anyways, if you have problems, we're always there to help you out. Okay, so let's go on with next problem. That is this. Use the Z transform to perform convolution of the following two sequences. That is, h of n is one signal, x of n is another signal. I know you're not comfortable with convolution operation, but we are not doing convolution operation. They are asking us to do convolution operation. Okay, but we'll be dealing with this in a different way. What is convolution property telling you in Laplace transform? We have seen. Okay, the convolution in time domain is multiplication in Laplace domain. Similarly, here in Z transforms, one of the properties says, the convolution property says, the multiplication, the convolution in time domain is multiplication in Z domain. So what they've asked is to obtain the convolution of this. So in time domain, we need to do convolution of this, which is quite difficult and we don't know that also as of now. Okay, so what shall we do? We shall obtain the Z transform of this and Z transform of this. And in Z domain, it would be multiplication of this. That is what we are going to see that. Now, we have to understand these signals. What is this h of n? H of n, what is the range of h of n? The range of h of n is 0 to 2. And from 0 to 2, what is h of n? It is half power n. What is x of n? X of n is delta of n minus 1 plus 4 delta of n minus 2. So this is also, how many samples are there? There are 3 samples here and there are 3 samples here. This is also starting from 0 going till 2. This is also starting at 0 and going till 2. Everybody's okay with that? Yeah. Now, the property says that convolution in time domain is multiplication Z domain. So let's not convolve, let's multiply. And for multiplication to be done, you need to be in Z domain, not in time domain. So let's get into Z domain now. So the meaning of this statement is this. If you have y of n, which is convolution of these two, then if you apply Z transform on this, this convolution operator would become a simple multiplication operator. This is what we are intending to do. Yeah. So first let's get h of z in place. What is h of z? H of z is Z transform of h of n. And h of n ranges from 0 to 2. And from 0 to 2, what it is? From 0 to 2, it is half power n. Okay. So how can we write this? It can be written as 1 plus half 1. Why it is 1? Because it is half power 0. Half power 0 is what? 1. Isn't it? So that, and when you have 0 here, you have 0 here also. You have 1 into 1, that is 1. So this is 0th sample. Then we have n equal to 1. If you make n equal to 1, it is half into z power minus 1. If you make n equal to 2, it is 1 by 2 to the power 2, that is 1 by 4 into z power minus 2. So this is how we have obtained h of z. Okay, this is how we have obtained h of z. Let's obtain x of z. To obtain x of z, we need to consider x of n. What is x of n? X of n is this. In place of x of n, we have substituted this. Now you need to again remember which property. We need to remember this shifting property of delta function or shifting property of unit impulse function. So how does it look like? Okay, so you need to bring this summation here, summation n ranging from minus infinity plus infinity delta of n into z power minus n. So this comes here, and this summation and this z power minus n is associated with every term here. Okay, so what would be the first term turns into? So delta of n z power minus n is there, and along with that you have this. So using the shifting property, so this is delta of n, this is z power minus n. So where is delta of n existing? This is existing at n equal to 0. So the first part would be z power of minus n being evaluated at n equal to 0. Similarly, this delta of n minus 1 is existing at n equal to 1. So this z to minus n would be evaluated at n equal to 1. And since this is existing at n equal to 2, z of minus n would be evaluated at n equal to 2. Okay, so this 4 is associated with that. That scalar is carried forward. Okay, so after you evaluate those terms individually, your x of z looks like this. And we know when we have x of z and h of z in hand, we can easily obtain y of z, which is multiplication of the two z domain signals. This is how it becomes y of z. Okay, now see here. So if you multiply these two signals, you would get this. So what we have got here is y of z. But what they've asked us to find out the convolution. Y of z is not the convolution. Y of z is multiplication of h of z, x of z. Now if you have to, they've asked us to obtain y of n. We have y of z in hand. So how to obtain y of n? If I give you y of n, you will give me y of z by applying the z transform. So if I give you y of z, how will you give me y of n? By applying the inverse Z transform. Why we have to apply inverse Z transform? I'll tell you. See here, in this, let's understand. They have asked us to find out the convolution of these two, which we have represented as y of n. Okay, since the convolution was difficult for us, since the convolution was difficult for us, we went to z domain and did multiplication operation. But obtaining y of z is not obtaining the convolution. Convolution is actually in time domain. So from y of n, you have given y of z. So how to obtain y of n back? So you need to apply inverse z transform. You need to apply inverse z transform. Okay. So how to do that? Inverse z transform we have not applied till now. This is the first time we are applying inverse z transform. So when would you have z inverse in z domain? You need to comment on that. Let's see how many of you will understand. When will we have z inverse or any power of z in z domain? Which signal would give us the powers of z in z domain? Can you remember? Okay, I'll tell you. Now, let me ask you this. Which signal has z transform equal to 1? Which sequence or signal has z transform equal to 1? Delta of n. Okay. Delta of n has the z transform equal to 1. Okay. So this is z transform of delta of n. So what is inverse z transform of this? The inverse Z transform of this would be delta of n. Okay. Similarly, if you have delta of n minus 1, delta of n minus, you can make a note there somewhere if you're not able to imagine. Okay, delta of n minus 1. If we have delta of n, the Z transform is 1. If you have delta of n minus 1, the Z transform is Z inverse. Okay, so that is here. So delta of n minus 1, if you have Z transform, that is this. So if we apply inverse Z transform, we'll get delta of n minus 1. If we apply inverse Z transform of this, we'll get delta of n minus 2. If we apply inverse Z transform on Z of minus 3, we'll get delta of n minus 3, and it is delta of n minus 4. That is what is our inverse Z transform application. Okay, and that is how we are obtaining y of n, and this is the convolution that we had to obtain. We obtained the convolution by going into Z transform. By multiplication we obtain y of z, then again coming back time domain we obtain y of n, and this is what is our convolution. How did we do that? By applying the inverse Z transform. So if you know the Z transform, inverse Z transform is not at all a problem. Okay, so let me see how many of you can tell the inverse Z transform. I'll give you these parameters in Z transform. You have to give me what is the inverse Z transform of that. Okay, if you have delta of, if you have let me Z by Z minus 1, Z by Z minus 1. What is the inverse Z? What is the inverse Z transform of Z by Z minus 1? Whether it is U of n or minus U of minus n minus 1. Confused? Z by Z minus 1 is the Z transform of U of n or minus U of n, U of minus n minus 1. For both U of n and U of minus n minus 1, it is Z by Z minus 1. Where is the difference then? The difference is in region of convergence. Understand that point? So difference is in region of convergence. So we need to understand region of convergence and then come back. Let's not get into that. Give me the Z transform of Z by Z minus A. The inverse Z transform Z by Z minus A. Z by Z minus A is the Z transform of what? It is A power n U of n. Okay. So if we know these Z transforms, applying inverse Z transforms will not at all be a problem. So you need to write the Z transform pairs for that. The Z transform pairs. If you apply Z transform on left hand side, you will get into Z domain on right hand side. If you apply inverse Z transform on right hand side, you will get back to time domain on left hand side. Okay, that is how it is. We'll solve more problems on inverse Z transforms. This is convolution problem, right? So in convolution problem, this inverse Z transform has to be applied because we need to come back in time domain. So to coming back to time domain takes inverse Z transform. So this is how we have obtained that. So if you know this Z transform of delta of n minus 1, you'll be able to do this. Otherwise, no. So you need to be good with the list of transforms we have done till now, the standard transforms. Okay. So go have a look into that. You will be finding it easier. Fine. Let's go on with the next problem. What is this problem telling you? Find the value of x of 0 for the sequence that has the Z transform x of z equal to 1 by 1 minus 1 half z inverse, and the region of convergence is given to be z greater than half. So for the first time, they have asked us to find out x of 0. Okay. So in which theorem we were able to, we wrote the equation for x of 0? Any idea? X of 0 is initial value. So this is initial value theorem. But initial value theorem is applicable to causal sequences. What are causal sequences? The right-sided sequences. So do you think this is the Z transform of right-sided sequence? Seeing the ROC, you should be able to tell that. Seeing the X of Z, you will not be able to say that. But seeing the ROC, you will be able to say that. Is X of Z is the Z transform of a signal which is right sided, so that you need to tell seeing the ROC. So this is something that one needs to understand. X of z is given. So seeing x of z, is it possible to say whether it is for right-sided sequence or left-sided sequence? No. But yes, seeing the region of convergence, we can comment on whether the signal is positive timed or the negative timed. So can you make out whether this is positive time or negative time? Why in chat window you're giving your names? Just a sec, we still have time. Don't give your attendance. Just okay, I'll give you time for that. Just give P sufficient. Your tag, your name will come along with it. Okay. So region of convergence is for z greater than half. Z greater than half means it is outside the circle with half as the radius. It is outside the circle means it is right sided. Understand that? So the sequence is causal sequence or it is right side sequence. So initial value theorem can be applied. So how to apply the initial value theorem? Yes, see, using the initial value theorem. Fine, using the initial value theorem, we can do that. See here, everybody, this is the initial value theorem, which says that x of 0 can be obtained by applying limit z tending to infinity on x of z. So on this, if you apply z transform, you're through. X of z can be written as this in terms of z. Apply z transform on that. Apply z tending to infinity, that would become 1. How it would become 1, you need to understand. Okay, because it is infinity by infinity. If you apply z tending to infinity, it is infinity by infinity. Infinity by infinity is not what? Infinity by infinity is not a determinant form. It's indeterminate. Okay, so what you need to do? Which law we need to be using if we have infinity by infinity, in which you differentiate both numerator and denominator with respect to z? Okay, so doing that, we have obtained the limit x of z as 1. So what we obtained is x of 0. So this is my initial value theorem. So if you are asked to obtain x of 0, okay, you can obtain that by initial value theorem. But yes, you need to be understanding what is this. Okay, so I'll give you attendance fast. We have less than a minute. Okay, so we'll see this. We'll discuss more on this in the next class. So on, give the attendance.